And it's not going to be the typical plug it into the calculator, hit equals, and see what you get. What we're going to be doing is modeling the addition, understanding what it means to be a negative number and a positive number, and what it means to represent those, because that's kind of where a lot of people struggle. The example problem that we're starting with is 2 plus negative 5. And here's how we're going to model those. We're going to have yellow tiles that represent positive numbers. So I've got one tile here, one tile here. Together I have 2 positive tiles. So that represents my first number right there. Then I'm going to add to it 5 negative tiles. Our negative tiles look like this. So that represents our 5 negative tiles. So I've got 2 negative tiles and 2 positive tiles and 5 negative tiles. What do you think it equals when I put a negative and a positive together? Is that 0? That is 0. That is what we call a 0 pair. Together, the pair of them equals 0. They just kind of cancel each other out. So those cancel each other out. I've got another 0 pair. What am I left with? Sammy?
Negative 3. Like with negative 3 tiles.
So my answer here is negative 3. The way that we write that is we have 2 positive tiles and we have 5 negatives. 1, 2, 3, 4, 5. And we just circle our 0 pair and we're left with 1, 2, 3 of our negatives. Let's look at negative 4 plus 5. Same type of problem. On your paper, represent the 4 negative tiles. And then we add to it 5 positive. 1, 2, 3, 4, 5. How many 0 pairs do we have here? 4. We've got 1, 2, 3, 4. So when we had our 4 negatives and 5 positives, that leaves us with that 1 positive. So our answer here is just a positive 1. The idea is that we're modeling those addition problems. There is a second way that we're going to be using to solve these types of problems. We're going to be using a number line. There's a positive 10, there's a negative 10. 1, 2, 3, 4, 5, that is there. 5. So we've got our number line there. So the other common way is, like I said, using a number line. If I look at our first example, this number right here is the number that I start at on my number line. So I'm going to start at a positive 2. That's 1, 2. So I'm going to start right here. Then I'm going to add 5 in the negative direction. So the second number is telling us which direction and how far to go. So I'm going to go 5 in the negative. 1, 2, 3, 4, 5. What number did I end at? Here's negative 1, negative 2. What number did I end at right there? Okay?
Negative 3.
Yes, you end right there at a negative 3, which is exactly what our answer was here in our first problem. In our second example, we're starting at the negative 4. So now we're going to start here at our negative 4. And we have to go 5 in the positive direction. We're adding 5 in the positive direction. That's going to give us 1, 2, 3, 4, 5, which has this end right there at a positive 1, which again is what we found to be our answer. So those are 2 different ways that we use to solve integer problems. Let's look at two more examples. Represent that using tiles on your paper. Anybody want to come up and model it on our screen? Julian, come model that on our screen. Let's see if you guys can have the same thing up there as Julian. So the red ones are negative and the yellow ones are positive. See that? Oh. Yeah, you can put it on the screen for them to see it. He set them on a desk, by the way. It looked good on the desk. Be patient. You're driving the classmates crazy, I think. All right, so we've got. Well, now I can't see the problem. All right, so we've got. Thank you. Do we agree or disagree? Excellent. Thank you, Julia. Thank you. So we start here with three positives. We start here with the three positives. Then we add those 6 negatives onto it, but then we have 3 more positives that we have to add on. And now we can make our 0 pairs. Here's a 0 pair, here's a 0 pair, here's a 0 pair, 0 pair, 0 pair, 0 pair. What am I left with? You're left with a 0. -3 plus -3. A lot of times when you have an addition sign, when you have a sign and there's a negative that is right after it, a lot of times you'll see that in parentheses. Mathematicians don't like to have their signs next to each other. A plus sign next to a negative sign looks kind of strange. So what they do is they put these parentheses around the -3 just to make it really clear that that integer is what you're adding to that integer right there. So you got -3 plus -3. Anybody want to come up and model that for us? Anna? Let's see if you got the same thing. By the way, this is one of the most commonly missed problems. This is one of the most commonly missed problems. Do we agree or disagree? Agree, I do too. Excellent work, excellent, thank you. So we've got 3 negatives, 1, 2, 3, and then we've got 3 more negatives, so what's our answer to this problem? -6, absolutely. -6. I mentioned that this is one of the most commonly missed problems. Why do you think this might be the most commonly missed problem? Scout? What do you think the most common answer is when they miss this? Zach? 0? A lot of people put 0 as an answer because they see there's a 3 and there's a 3 and then a plus and then there's a negative here, so when I add these they'll give me a 0, and that's not the case. A lot of times those get lost. Excellent, excellent work. You can also use the number line to solve that problem. If you start here at the -3, we're going to start right here at -3, and then we're going to go 3 more in the negative. That's 1, 2, 3 more in the negative. That ends right there. at our -6. So very, very good. Excellent.